Learn it fast, learn it smart, learn with us at Sofo. Subscribe now for more videos. Contact us for on-demand and regular tuition classes.
In this video, we will focus on the division algorithm for polynomials. If you remember, we had already evaluated the division algorithm for numbers, but in this video we will look at that algorithm for polynomials. But before we get into this, let's recap some of the concepts that we have learned so far. In polynomials, right, what do we mean by degree of a polynomial? It is the max exponent or the highest power of the variable in the polynomial is called the degree. Then 0 of a polynomial is the point where the polynomial p of x is equal to 0. Remember, this is not the point where x equal to 0, it is the point where p of x, the entire polynomial, is equal to 0. The next concept that we want to just recap is that degree is the max number of zeros of a given polynomial. So if you have a quadratic polynomial of degree 2, then we can have at most 2 zeros when we solve that polynomial. And lastly, what is the standard division algorithm? Let me just state that. Let's say we have two numbers, a divided by b, and this is equal to z, with a remainder r not equal to 0. Then what we have is a is equal to b multiplied by c plus r. This relationship is called division algorithm, and we are going to look at this concept for a polynomial scenario. Okay, now we will try to understand this concept in detail, and a key ingredient is the mechanics of polynomial division. The mechanics is fairly similar to the mechanics that we are already familiar with for numbers, but the key difference is that a polynomial has more than one term. A number has only one term that we want to focus on. Polynomial has more than one term that we have to focus on. So the way we do it is to sharpen our focus to the highest order term in the polynomial in order to create the division mechanics. So let me show you through an example. Okay, so I have an example here. So this is the numerator or the dividend, 2x squared plus 3x plus 1, and the denominator or the divisor is x plus 2. Now, the way the mechanics works is that we focus on the highest order terms in both places. So here you think about this 2x squared, and here you think about x. So let me change the color and show you. For step 1, we will focus on 2x squared divided by x, and you're going to get 2x as the answer. Now we multiply this 2x by this expression x plus 2, and we get basically 2x squared plus 4x. All right, so this 2x comes here, and we do this 2x squared plus 4x right here. These multiplied comes here, very similar to how we do it in the numerical model. Now let me change the color again. Now if you subtract, you're going to get 0 here, and when we subtract this, you're going to get negative x. All right, now let's bring down the third term plus 1, so we get negative x plus 1. All right, now in this term we would focus on this term and this term. So it is negative x divided by x or equal to negative 1, and then we multiply that with this expression, so negative 1 multiplied by x plus 2, or we're going to get negative x minus 2. So you get negative x minus 2, and if we were to subtract, this would become 0, and this portion become 1 minus minus 2, or 1 plus 2, or positive 3. All right, so there we have it. I'm sorry, I should have written this minus 1 over here. This goes over here. So if you divide this expression by this expression, you get the answer as 2x minus 1, and you get a remainder of 3. Okay, so let me summarize. The original expression 2x squared plus 3x plus 1 divided by x plus 2 yields the expression 2x minus 1 with a remainder 3. Now we can express this as a division algorithm straight away, which is this term 2x squared plus 3x plus 1 is equal to these two terms multiplied together, so 2x minus 1 times x plus 2 plus 3. I urge you to do this, multiply these two things at home and add 3, see if you get this, and I am pretty confident that you would be able to prove this equality. So there you have it. That is the fundamental nature and concept of the division algorithm for polynomials. Now I want to demonstrate this concept for a more complicated higher order polynomial, which we will look at next. Okay, so here we have two expressions, 2x to the power of 4 minus 3x cubed minus 3x squared plus 6x minus 2 to be divided by x squared minus 2. All right, now as we talked about in the previous portion of this video, right, our first step is to focus on the highest order in both expressions, which is 2x to the power of 4 and x squared, right? So the first step is, let's do 2x to the power of 4 by x squared, and we're going to get 2x to the power of 2. 2x to the power of 4 by x squared is 2x to the power of 2. Now we do 2x squared, which is this, multiplied by this expression, x squared minus 2. And what do we get? 2x to the power of 4 minus 4x squared. All right, now this is going to go over here so that we can subtract. Okay, now from this point we need to conduct the subtraction, which makes it 0 here, and we get minus 3x cubed, and this, when you subtract, this will become positive 4x squared minus 3x squared, so this is plus x squared plus 6x. All right, now our next step focuses on this 3x cubed and x squared. All right, so second step is 3x cubed by x squared, which will yield 3x as the solution. Now we multiply this with this term, so 3x multiply x squared minus 2, and we're going to get 3x cubed minus 6x. There is a small correction. I had missed a negative sign over here, so this is minus 3x cubed. So you get minus 3x. So we need to put a negative sign here and a plus sign here. So when you multiply, you get minus 3x cubed, and when you multiply this, you get positive 6x. Now let's transfer it with this minus 3x over here. This goes here, and this minus 3x cubed, and the plus 6x comes here. So what we get is, this is 0, and we get x squared, and this is 0, and you get minus 2 over here. All right. Now it is fairly simple because these two are the same. So therefore you just do a plus 1, and 1 times this is this, and you get the rest as 0, remainder as 0. So what this shows is that the process of division of two polynomials is fairly similar, but all you have to do, think about as a difference from the numerical process, the process that you use for pure numbers, is that you focus on the highest term, the highest exponent term of both expressions in the numerator and denominator as you go through the division process, and you keep eliminating. All right, there you have it. You can double check the multiplication of this term and this term to see if you get this term with 0 remainder, and that would prove the division algorithm for polynomials. Thank you for watching.